Today we're going to be talking about algebra tiles. When we do, we're going to be talking about adding integers, subtracting integers, multiplying integers, and dividing integers. Now you might be asking yourself, what in the world are algebra tiles? They're these little guys. These represent constants. We also have these things. These represent the x variable. And also we have these, which are the x squared. Now today, when we're talking about adding, subtracting, multiplying, and dividing integers, we're not going to be worrying about the x variable today. You'll see that in a later video. But today we're going to be talking about adding, subtracting, multiplying, and dividing integers. Each one of these represents an integer. So this is 1. These together would make 2. These together would make a negative 2. I could flip all of these over, and these would be negative 5. Now your set of algebra tiles might have different colors, but for most of them there's going to be a red for the negatives and some color for the positive. My set has a cream back for the positives. So let's look at adding integers first. So before we begin, let's represent this with algebra tiles. Now I know most of us might know what 4 plus 5 is, but it's good to be able to represent this physically because later on we're going to be talking about some harder concepts with algebra tiles that might for the first time make mathematical things make physical sense. So we need to make sure I have a good foundation. So here I have 4 plus 5, and so if I add these together I end up with 9. So 4 plus 5 is 9. So let's take a look at this one. I have negative 2 plus a negative 6. So I can represent negative 2 like this with the 2 negatives, and negative 6 with 6 red negatives. So I have negative 2 plus the negative 6. That gets added together, and I have 8. Actually, I have negative 8. So sometimes a lot of people get confused by the negatives and they want to make up crazy math rules they have to follow with negatives. But if you think about this physically sometimes, like negative 2 plus negative 6, there's no weird math trickery. It's just simply adding these negatives. I have a negative 2, negative 6, and that becomes negative 8. Here I have algebra tiles already represented and pre-printed for me. So I have a 5 and a negative 2. So I could write this as 5 plus a negative 2. So if I'm to add these together, how would that work? Well, let me represent it with physical tiles I can manipulate and move around over here. So 5 plus a negative 2. If you notice, these previous two, they had the same sign. This one, they have different signs. So if we put this together, I have a positive and a negative pair. This together, I have another positive and negative pair. We call these zero pairs. 1 minus 1 is 0. It goes away. 1 minus 1, it's 0. It goes away. So all we're left with is 3. You can think about this physically here. This one's going to cancel out with that one. And this one is going to cancel out with this one. So we can see that we are going to be left with 3. In a minute, we're going to be talking about subtracting integers, and it is possible to represent this as 5 minus 2. That's probably a more familiar way you've seen this written, and you've probably seen this written as negative 2 minus 6. That's the same thing, and actually a little bit more of a simplified form. But it's helpful sometimes just to be thinking that these things are just adding negatives. These 3 questions I want you to do on your own. You're going to see the symbol often in my videos. It says pause and try. What's going to happen in the video is going to play for about 5 or so seconds. And then I will continue with an explanation. It might jump to an explanation on some problems. Some problems I might just go ahead and work it out, but you can safely pause it, hit play in a little bit whenever you get your answers ready to go so that you can actually check your work. It's imperative that you actually do math whenever math problems are presented to you. Otherwise, you're not going to learn. You have to think to learn. So go ahead and pause the video and try this. Okay, now let's check your work. Whenever you see this symbol, you know that we're going to be checking the work. So if you're ever scrubbing around through the video, you can maybe look for that to help you out. So let's check our work. So we have -7 plus 3. We have 3 0 pairs that pair up and become 0. So these are going to go away, and we're left with 4. Then I have a +3 plus a -3. Each of these also pair up, and then you're left with just 0, because really this is just 3 minus 3, which is 0. And lastly, we end up with -3 plus 7. So this -3 plus 7, these eliminate out. This pair cancels, this pair cancels, this pair cancels, and we're left with just 4. Now let's talk about subtracting integers. So let's take a look at these. All I've done from the previous addition questions is I've just turned them from addition to subtraction so we can try to draw some parallels. So I now have 4, +4, and then I have a minus a +5. So I'm going to first put them down as a +5. So we're being told to subtract. Well, if I have 4 minus 5, which is what this really equals, we can view these +5s as negatives. So in a way, we're sort of kind of change this positive into a negative. So if I'm going to do that, I need to flip all these over. If it's positive, it becomes negative, and if it's negative, it becomes positive. So this really is just 4 minus 5. So if you see this 4 minus 5, I have 4 pairs that pair up, and I'm left with just -1. Next up, I have -2 minus a -6. So if this is -2 minus 6, in order for me to take this minus, I'm going to need to change this sign. So these become a +6. So in reality, this is -2 plus 6. Because if I minus a negative, I'm really just adding 6. So I have 2 pairs, 2 0 pairs right here. Those go away, and we are left with just +4. I just realized I have the same thing here. That's funny. It should be, this should be 5 minus a -2. So if I have 5 minus a -2, let's have a +5. Minus a -2. So I have +5 minus a -2. That really becomes 5 plus 2. Which of course is 7. Next, I want you to pause the video and try these 3. So let's do a little halfway check. So if you just look at these second terms here, I have a +3, -3, +7. These subtractions are going to require me to flip the sign. If it's positive, it becomes negative, and if it's negative, it becomes positive. So take a second. Again, let's pause the video and finish that up. So now let's check our work. We should end up with a -7 minus 3, which is a -10. 3 plus 3, which is 6. negative 3 minus 7, which is negative 10. I want you to notice something about this question and this question. They end up with the same result, and they have the same numbers, just in a different order. This goes to show that if I have a negative 7 minus 3, it's the same thing as negative 3 minus 7. This is the commutative property. As long as that sign sticks with it, then it's going to be the same thing. Over here, if I was just to switch the 4 and the 5, but not the sign, and have 5 minus 4, I would have a different number that would be a positive 1. So if I was to move that negative 5 over, swap that around so it's a negative 5 plus 4, we would end up with that negative 1. Okay, let's continue with multiplying integers. So, before we begin, let's see if we can represent this. So I know I have a 3, and I know I have a 2. But this is different than the adding or subtracting. It's not just 3 plus 2 and it's 5. This is multiplication. So what this literally means, this is 3 times 2. So you're going to do 2 3 times. Okay? So it's 3 times 2. So I'm going to have a 2 and a 2 and a 2. This really means I have 3 sets of 2, 3 groups of 2. So if I have 3 groups of 2, how many individual units do I have? We have 6. Another way to represent this, instead of 3 groups of 2, is we could represent this as 2 groups of 3. So these same dots over here, I can make a group of 3, and then make a group of 3, and we get 6. Again, this is the commutative property. So, if I take a look at this, there's one more way I could physically represent this. I can view this as a column of 3, 3 by 2. Okay, now I can represent this as 2 by 3. Which is the same thing as me saying I have my 2 groups of 3, but I can put together, and this can look like an area thing. Sort of kind of like if you were to be tiling a bathroom or tiling your backsplash in your kitchen, and you're wanting to take a look at that area of the number of tiles of 2 by 3. This is going to be important later when we talk about foiling. But for now, this is another way to sort of visualize this issue. Let's take a look at 2 times negative 4. So I have 2 groups of negative 4. So let's make one group of negative 4. And let's make another group of negative 4. So in total, I have 8. But notice they're red, so that tells me that it's going to be a negative 8. So I could, again, just to show the commutative property, I could have negative 4 times 2. This is a little weird because I have negative 4 groups of 2. That just sounds weird in my brain a little bit. But nonetheless, let me make groups of 2. Groups of 2. Groups of 2. Group of 2. And a group of 2. So if it was just 4 times 2, I would have 4 groups of 2. But that negative's there, right? So if I have 4 groups of 2, but that negative is going to make my groups, going to flip the sign on my groups, and so I have a negative 4 groups. Does that make sense? I had 4 groups, but I had to negate them, so now they are negative 8. Let's take a look at 5 times 1. So I have 5 groups of 1. So there's 1, there's another one, there's another one, there's another one, and there's another one. So how many do I have? Simply put, I have 5. So let's commute it. 1 times 5. So this is I have one group of 5. So these over here, one group of 5, which of course is 5. Here's a set that I want you to pause and try. As a checkpoint, in case you are stuck, let's take a look at what I have so far. So I have 4 groups of 4, 7 groups of -2, but this one's the tricky one that you might be stuck with. So I have 5 groups, ignoring that negative for just a second. I have 5 groups of -3. 1, 2, 3, 4, 5. But it's being negated. I have these -3 that's being multiplied by this -5. I have -5 groups. So what I need to do is I need to negate these. So I'm going to flip these over, continue flipping all these over, and then answer the question. So you can go ahead and pause and finish this up. Let's check our work. So here, after I've negated those, I end up with a positive 15 because I have 15 of those. 4 times 4 is 16, and 7 times this -2 is a -14. I want to see if you can think through these and try these on your own. In a second, I'm going to have you pause the video and try these. I'm going to give you a hint the next time I come back, but I just want you to try these on your own for just a minute. Okay, I want you to notice something. All the numbers on this page are negative. That's on purpose. I want us to see what happens when we're multiplying by negatives, and we can see that in these algebra tiles. So here I have -4 and this -2. So that's why I have 2 groups of the -4. But again, that's negative, so we need to negate these groups. So now I have 8. This 8 is getting multiplied by this -3. So what I'm going to do is I'm going to take a group of 8, and I'm going to have 3 groups of 8. But don't forget about the negative, so I'll come back in just a second. So go ahead and pause and see if you can finish this up. I have 3 groups of 8, but that pesky negative is there, so I'm actually multiplying by a -3, so all of these need to get negated. So once I flip all these over, you'll see that there are going to be 24 squares, and each of them are going to be negative. So this will end up being -24. I want you to follow this same procedure with the question on the bottom. Remember to work within these parentheses first. Simplify this first, and then multiply them together. We can see that this is a +6 times a +8. So now all I need to do is just to multiply those together. So I'm going to make 6 groups of 8, and that will be my final answer. You might not have as many algebra tiles as I do, but I ended up with 6 groups of 8 for a total of 48. Notice this was positive, but this one was negative. Up here I had 3 negative numbers that got multiplied together, and I got a negative number. Here I had 4 negative numbers that got multiplied together, and I had positive. What do you expect would happen if I had 5 negative numbers, or 6 negative numbers? If I multiplied in another negative number here, regardless of what this number would end up, this would end up with a negative value, because multiplying in that another negative would be like this version here with 3. If I multiplied in another pair like this, it would end up being positive. So you can see this pattern that we have here. If we have an odd number of negative numbers, it'll end up being negative. But if I have an even number of negative numbers, my resulting number will be positive. Our last topic is to talk about dividing integers. So I'm going to take these are the answers from the previous pages, and divide it by some of the values that we multiplied together. So earlier we did 3 times 2 and we got 6. So I'm going to just simply show how we go take 6 and divide 3 and get our answer. So let's start with 6. Okay. How can I divide 6 into 3 groups? Sometimes you might wonder, why do we call it division? Why are we dividing? We are literally going to divide 6 into 3 equal groups. So 6 divided by 3, and when I put them into 3 equal groups, what's left over in one of those groups? It's just 2. So let's do the same thing, but let's divide by 2. So if I have 6, and I divide them into 2 equal groups, how many are in just one of those groups? Just 3. Earlier, we took 2 and we multiplied it by -4, and we got -8. So let's start with -8. And let's divide that into 2 equal groups. So if I divide that into 2 equal groups, I get 4 in one of the groups. Actually, -4 in one of those groups. So 8 divided by 2 is -4. If I have this -8, and I divide it by -4, so ignore the negative for just a second, put it into 4 equal groups, we should get this. But if I have -8 and I'm dividing by -4, this negative, I'm going to have to negate what's happening, which means I'm going to flip these over. So in each group, what do I have? I just have a +2. You might recall from elementary classes that we have these things called fact families. 2 times 3 is 6, and 6 divided by 3 is 2, and 6 divided by 2 is 3. They all work and play together. That's sort of what we're seeing again here, but this time with the negatives. 4 times -2 is -8. -8 divided by 2 is -4. -8 divided by -4 is +2. Last thing for this video, I want you to pause and try these. Okay, let's check our work. So I have 5 divided by 5. How can I split this up into 5 equal ways? Well, just like that. And in each group, there's just going to be 1 left over. I have 5 divided by 1, so 5 divided into one group. There's just 5 items in that one group, so I have 5. Here, 15 divided by 5, I end up with 3 in each group, but it's 15 divided by -5, so they get negated. And so what's left over in just one of the groups is -3. Here I have 15 divided by -3, so I can split them into their own group this way, but like I said, it's a -3, so it's going to be negated, so they all flip over. So in one of these groups, I'm left with just -5. I hope you've been able to pick up a few things about algebra tiles when you add integers, subtract integers, multiply integers, and dividing integers. In my next video, we'll be talking about multiplying and adding polynomials